Alright, welcome to today's class. In this class, we are going to be dealing on surface tension. What is surface tension? Surface tension is the elastic force acting on the surface of a liquid caused by the attraction of molecules in the surface layer. The attraction is called cohesion. So surface tension is the elastic force acting on the surface of a liquid. It is also caused by the attraction of molecules in the surface layer. Alright, let's take an example of surface tension. Here we have a paper dropped in a bowl of water. A paper dropped in a bowl of what? Water. Alright, so this is a bowl of water. If you carefully drop a paper on the water, you would notice that the paper will float. It won't sink. But if you drop the paper forcefully, it will sink. So the reason why it floats here is because of surface tension. So it is surface tension that makes it not to sink. And why is surface tension acting here? Because the molecules on the surface of the water are attracted to each other. So for this paper to sink, it has to break the bond between the molecules. So if you forcefully drop the paper on the water, it will sink because it has broken the bond between the molecules. Alright, so another example of surface tension is tap water and its droplets. If you put off a tap, a running tap, you would observe that droplets of water would be found. Kindly put off a running tap, probably in your bathroom or in your kitchen. You would observe that little droplets of water would come out of the tap. So these are the droplets of water. So this is as a result of surface tension. Alright, before we proceed, if you are new to this channel, kindly subscribe now. Ensure you like this video. And if in the course of this tutorial you have a question, endeavor to leave your question in the comment section. Alright, so surface tension can also be defined as the force acting per unit length of a liquid. The coefficient of surface tension is called gamma. The coefficient of surface tension is called gamma. This is gamma. Alright, so mathematically, from this definition, surface tension can also be defined as the force acting per unit length of a liquid. So mathematically, surface tension gamma is equal to what? Force all over what? Length. Surface tension is equal to force all over length. So gamma is equal to F all over L. Alright, so let's call this equation 1. Alright, now let's make F the subject formula. If you make F the subject formula, you will cross multiply. So if you cross multiply, you will have that F is equal to gamma multiplied by L. So let's call this equation 2. All right, let's consider water droplets from the tap. This is the tap, and these are the water droplets. So if you look at this water droplet, you would see that it looks like a sphere. It looks like a sphere. It looks like a what? A sphere. So this is it. It looks like a sphere. But if you look at it from the top, it would look like a circle. If you look at this water droplet from the top, it would look like a circle. All right, let's use the circle for our calculation. Let's use the circle. Or this is called a what? A circle. I got this circle from the water droplet. Remember, if you look at the water droplet from the side, it looks like a sphere. But if you look at it from the top, it would look like a circle. All right, now let's find the perimeter of a circle. The perimeter or circumference of a circle. So what is the perimeter of a circle? The perimeter or circumference of a circle, L, is equal to 2 pi r. That's the formula for the perimeter of a circle. All right, now let's substitute the value of L into F. Remember that F is equal to gamma multiplied by L. So if you substitute the value of L, F will be equal to gamma multiplied by 2 pi r. Remember, L is equal to 2 pi r. So let's call this equation 3. Let's call it equation 3. All right, so let's look at the droplet again. Now look at this droplet. As the droplet falls, it has a weight of its own. The droplet has a weight of its own, and it also has a height of its own. All right, so assuming this is the droplet, it has a height of its own, and it also has a weight. Now remember that weight W is equal to mass times acceleration due to gravity. Weight W is equal to mass times acceleration due to gravity. So let's call this equation 4. Also remember that density rho is equal to what? Density is equal to mass all over volume. This is the equation of density. So rho is equal to what? M all over V. So now let's make mass the subject formula. If you make mass the subject formula, mass will be equal to rho multiplied by volume. All right, so let's call this equation 5. All right, so let's substitute mass into equation 4. All right, substitute equation 5 into equation 4. All right, so if you substitute equation 5 into equation 4, weight W will be equal to rho multiplied by volume and then multiplied by G. So weight is equal to rho multiplied by volume and then multiplied by G. So let's call this equation 6. All right, now recall that volume, recall that volume V is equal to area multiplied by what? Height. Volume is equal to area multiplied by height. And also remember that we are considering a circle. We are considering what? A circle. So what's the area of a circle? The area of a circle is equal to pi r squared. So this is the area of a circle. So if you substitute area into volume, you would have volume V is equal to pi r squared multiplied by height. So let's call this equation 7. All right, so since we have V in equation 6, we can now substitute equation 7 into equation 6. So substitute 7 into what? 6. So if you substitute equation 7 into 6, weight W will be equal to rho, open bracket, pi r squared multiplied by height and then multiplied by G, which is acceleration due to gravity. So if you open up the bracket, you would have weight is equal to pi r squared and then rho GH. So let's call this equation 8. All right, let's equate equation 3 to 8. Equating equation 3 to 8. Now, what is equation 3? Equation 3 is what? F. And F is equal to 2 pi r and then multiply by what? Multiply by gamma. And then equation 8 is W is equal to what? Pi r squared and then rho GH. So this is equation 3 and equation 8. Equation 3 and equation 8. So if we equate equation 3 to equation 8, we would have 2 pi r and then gamma is equal to 5 r squared and then rho GH. All right, so at this point, we are going to divide through by 2 pi r. Divide by 2 pi r. So if you divide both sides by 2 pi r, you would have 2 pi r and then gamma, open bracket, divided by 2 pi r is equal to pi r squared and then rho gh divided by 2 pi r. So here 2 pi r cancels 2 pi r, and then pi cancels pi. R here is 1. R here, 1 is left. So we have gamma is equal to r rho gh divided by what? Divided by 2. So this is the formula for surface tension. Let's call this equation 9. So this is the formula for surface tension. All right, let's make H the subject formula. If you make H the subject formula, H will be equal to 2 rho, 2 gamma rather, divided by r rho and then g. So let's call this equation 10. All right. This. All right, if you are given angle of contact, therefore surface tension gamma will be equal to r multiplied by rho multiplied by g multiplied by h all over 2 cos theta. Remember that theta is the angle of contact. And then if you are given the angle of contact, h becomes 2 multiplied by gamma multiplied by cos theta all over r multiplied by rho and then multiplied by g. All right, so this is how to prove the formula of surface tension. If you've not subscribed to this channel, kindly subscribe now. If you have a question, endeavor to leave your question in the comment section of this video. And don't forget, please like this video and you can share to your friends. See you in our next class.